All right, let's dive right in. In the world of AI, it often feels like a battle of giants. But what if a new contender could enter the ring, not by being bigger, but by being way, way smarter and just radically more efficient? Well, that's exactly the story of DeepSeek V3, a new open source model that's delivering absolutely top tier performance at a fraction of the cost.
So you have to be asking, how on earth did they pull this off? Well, in this explainer, we're going to break it all down. We'll start by seeing where DeepSeek V3 fits into the whole AI arena. Then we'll unpack its incredibly clever design and the smart techniques they use to train it. After that, we'll see if all that efficiency actually holds up on the leaderboards. And finally, we'll connect all the dots to really understand why this is such a massive game changer for the entire open source community.
Let's get to it. First up, what exactly makes DeepSeek V3 such a potent new contender in the AI space?
Right now, the AI landscape is pretty much split into two big camps. On one side, you've got the closed source giants. Think GPT-4o. These things are incredibly powerful, but they're built behind closed doors by massive corporations. On the other side, you have the open source challengers. These models are built out in the open, which lets anyone build on them and innovate. And that's exactly where DeepSeek V3 comes in, aiming to completely erase the gap with the big guys.
Okay, just look at these numbers because they really tell the story. DeepSeek V3 has a staggering 671 billion total parameters. That puts it firmly in the heavyweight class. But, and this is the really clever part, it only ever activates about 37 billion of them for any given task. This whole power-on-demand approach is the secret sauce to its efficiency. And it's all thanks to a design called Mixture of Experts.
So how does it pull off that kind of efficiency? Well, that brings us right to Section 2, Built for Efficiency. This is where we get into the real engineering magic.
The core idea behind Mixture of Experts, or MOE, is just brilliant. Instead of having one giant brain trying to do everything at once, you have a whole team of specialists. So a math problem comes in, the model wakes up its math experts. It gets a coding question, it calls on its coding experts. This kind of specialization makes the entire system so much faster and way, way cheaper to run. The other key piece of the puzzle is something called multi-head latent attention, or MLA. Think of it like this. Instead of the model having to reread an entire heavy book every time it wants to find one piece of information, MLA creates a perfectly compressed, super detailed summary. This just drastically cuts down on the memory it needs, especially for long chats, making the whole process so much more efficient. So the model's architecture is clearly smart. But what about the process of actually training this beast? That brings us to Section 3, Smarter Training Techniques. The team literally optimized every single step of the way. They use something called FP8 training, which uses good enough numbers instead of perfectly precise ones to massively speed up calculations. They developed a dual pipe algorithm that acts like a perfectly coordinated factory assembly line, making sure the GPUs are always working, never just sitting around waiting. And finally, they wrote custom code to squeeze every last drop of performance out of their hardware. They left nothing on the table. And the result of all that incredible optimization? Just look at this number. The total cost for the entire training process was just over $5.5 million. In a world where training top models can cost hundreds of millions of dollars, a number like this it's just almost unbelievable. It's the direct payoff of all that brilliant engineering. And what's even more wild is how stable the process was. Training models this large is notoriously difficult. They crash, they have setbacks all the time. The fact that they completed the whole thing without a single major failure or having to roll back their progress, that is a massive engineering achievement all on its own, and it saved a ton of time and money. Okay, so it's cheap and efficient. That's great, but can it actually perform? That's the real test, right? Let's see how it does in Section 4, Climbing the Leaderboards. First up, let's throw it into the deep end with one of the toughest areas for any AI, math and reasoning. And wow, the results are absolutely stunning. On the math benchmark, which is a really tough standard for mathematical problem solving, DeepSeek V3 scores a 90.2. That's not just a little bit better. That is a massive leap ahead of both GPT-4o and Claude 3.5 Sonnet. It's blowing them out of the water. Okay, so it's a math whiz, but what about another super high demand skill? Can it write code? Yup, it's the same story all over again. On Live Codebench, which tests how well a model can solve complex programming problems,
DeepSeek v3 again takes the top spot, outperforming the leading closed-source models. This isn't just good for an open-source model. This is state-of-the-art performance, period. And it's not a one-trick pony either. Just look at this table showing its performance across a whole range of other tough benchmarks. It's super competitive in general knowledge, it holds its own against Claude on PhD-level questions, and it absolutely dominates in Chinese language tasks. This proves that this efficient design delivers truly well-rounded top-tier capabilities across the board. So let's step back for a second. What does all of this actually mean? Well, that brings us to our final section, and honestly, it's a big one. The open source game changer. The impact here is just huge. DeepSeek v3 proves you don't need a budget the size of a small country to build a world-class AI model. This dramatically lowers the barrier to entry, and it just blows the doors wide open for more researchers, startups, and developers to innovate on a powerful foundation. It bridges that gap to the closed-source giants and shows that the open-source community can not only compete, but actually lead in critical areas like math and code. And that leaves us with one final big thought. We've just seen that elite, top-of-the-line AI performance is no longer exclusively for those with the deepest pockets. The blueprint for building powerful, incredibly efficient models is now out in the open for everyone to see. So the big question is, now that this kind of power is accessible to so many more people, what incredible things will they build next?